Greeting from Thai style. Sawadee krab. Okay, good afternoon, everyone. So welcome to the special panel discussion on early warning. This session is organized by 4 key government organizations in Thailand. So, okay, I'm honored to be your moderator today. So, please do it our session in 30 minutes. Okay. Okay, let's get started. So first of all, as you remember, the southern part of Thailand suffered from the significant disaster last year, you remember, yes. And we have learned a lot of things. Actually, we are facing the increasingly extreme weather and also the complex weather phenomena. I believe there are many lessons to learn from those experiences. So today, in consideration of this kind of a significant disaster, I would like to hear a presentation from the government organization in Thailand and then proceed to a discussion regarding the early warning in Thailand. Okay, let me introduce today's leadership from Thailand government organization. First of all, from ONWR, Office of National Water Resources, we have Kun Kanjanawan. And then from DCC, Department of Climate Change and Environment, we have Kun Rabiab-san. And from DDPM, Department of Disaster Prevention and Mitigation, we welcome Dr. Seree, special expert in Thailand. And from TMD, Thai Meteorological Department, we have Kun Fatah-san. Fatah-san, thank you very much for your staying with us continuously. Okay, so first of all, from ONWR, so I would like you to provide presentation. Okay. Actually, I saw your presentation in advance. The keyword of this presentation must be single DDS, right? Okay. Okay. Shall we please start presentation?
Thank you. Good afternoon, everyone. My name is Kanjanawan Nilklud. I'm from ONWR. For today, I'm very honored to share our journal about the climate adaptation. And for today, our focus is on the critical role of the AI enhance the early warning system in Thailand. And I would like to show you how Thailand is transferring water management to build the national resilience. Okay, let's start with the first point. I would like to show you about our current strategy. We must look back in the big flood in Thailand in 2011 that the Thailand underwent the major reform of its about the water governance. And this is led to the 3 pillars. That is the Water Resources Act, and established the ONWR and our 20 years master plan. And our goal is to coordinate the over 50 agencies to ensure the long-term water security and resilience for our people and the country. And also, I would like to show you about the ONWR response. The ONWR is the hub of the water management in Thailand. And our responsibility is try to formulating the national water policy and the planning to the integrated water information from the various agencies. And crucially, we facilitate inter the agency coordination and support the National Water Resources Committee to ensure that every drop of the water is managed through the unified strategy lens. And this is all of the over the 50 agencies from Thailand. It is so complex about the water management that we have so many agencies from the Royal Irrigation, from the Meteorology department, and also the departments of the disaster prevention and mitigation also. That's our challenges. That is the integration data that is so important. That is where AI is become a game changer, acting as the bridge that connect this fragment solo into the single cohesive network. And this I would like to talk about the traditional statistic model. Nowadays, for each department, they have own information and own database. And also when the fast or the drought happen, that they reporting the water level and the discharge after the event happen. And also some time they input and release the data daily or weekly, not automatic somehow. And now and for the future, we try to shift to the bring the AI to learn our information. Like we would like to combine all information and all data from the over 50 agencies to the one bigger data like the National Water Data Gateway. And also this water data will be predictive and give the result about the impact-based forecasting. And also for the calculation, maybe that is timely for the release the flood announced to the people who live in the flood risk area. And this is our single decision support or DCS framework. We would like to operate the all-T scale. That is the first one, the national level. We try to focus on the policy list and the common operating picture. And the second is the basin level. We use the risk-wide simulation for the proactive management. And for the urban level, we try to provide a high restoration nowcast. That is utilizing inundation modeling to tackle the real-time alerts and local pumping plan action. And move to our purpose. For the early warning, we try to show you about the impact-based forecasting on the ground. Nowadays, we focus on the 34 important areas. That's it, from the Chiang Rai in the north to the Phuket in the south. That we would like to pinpoint inundation depth under the 1 meter. And we would like to use the AI system trigger specific alerts for the water economics and residential corridor. And this is achieved by the combining high resolution from the LiDAR. And they will calculating the flood risk area, and they will give the data to the public, and they will know exactly where will be the impact. And this is the funnel show the process from the impact-based forecasting. We integrated the hydro and the meteorological data through the AI to delivery decisions alerts, and the come out that is a community gains the early preparedness. That's taking the timely action. We reduce the life loss and the safeguard access, and strengthen the overall economic stability and resilience of our nation. And how to check the success, that we track the key performance indicator, or we call KPI. That we will check the KPI at every level, like from the national accuracy and speed to the difference, and especially the urban action plan. And however, this key to success is not the technology alone. It depends on the continuous data from the over 50 agencies and accuracy of the monitoring and evaluating refine our AI model. And this is a conclusion. AI is no longer just a forecasting tool. This is the central nervous system of the Thailand climate adaptation strategy. And our vision is a global one where the centralized government meets the cutting edge, the technology. We are ready for the collaboration, and we invite our Asia Pacific to exchange the technology and the data so we can build the climate resilience in the future together. Thank you.
Thank you, Kun Rabiab-san. So thank you for sharing now. Thailand is moving from separate data from 50 organizations to unified single decision support system. Thank you. Okay, shall we move on to the next? Kun Rabiab-san.
Yes.
So next, from DCC. So please go ahead with your presentation.
Yes. Thank you. Good afternoon, everyone. It's my great honor to participate in these forums. My name is Rabiab Poopha, Director of Climate Change Adaptation from Department of Climate Change and Environment. Today, I would like to present about Thailand adaptation strategic response to climate change risk, focusing on how we are moving from reactive to proactive measures by AI technology. This is everyone you know. Now we have above 1.55 Celsius already, and we have highly affected, especially for Thailand. We have losses effect by flood and drought, about $199 million. If you see, it have an impact for Thailand. This is a Thailand climate projections from 2100. If you see, you can see the rising temperature trend is high, and now we have a rainfall pattern to. If you see the 2040, you will see some area have like a decreased rainfall, some area increased rainfall. That's why the Thailand have the impact. The same period we have difference impact from drought and floods from the Thailand projection. This impact for climate economics, so we have an impact. That you can see that the climate change is becoming a major socio-economic challenge for Thailand. We face high flood risk and droughts and rainfall variabilities that's so wide have affecting for agriculture and vulnerable communities. If you see the first, at the first, you will see the most vulnerable country to river flooding mean our food security and rural livelihoods are at extreme risk. Without any adaptation intervention, we face significant crop yield decline by 2040, and it may reduce Thailand GDP too. And adaptation measure could limit loss to 8% with dry and wet conditions. Regarding to adaptation, about global goal on adaptation frameworks, if you see, we have a multi-hazard early warning system and climate information service that are two priority to key for this because it's we have achieved for Thailand National Adaptation Plans as well from global goal on adaptation. About AI, we plan to next year we have a plan to use AI for digital twin. We plan to at the south of Thailand at the Hat Yai, and now we prepare for this project. About digital twin, we use AI together with digital twin technology for high resolution climate model to support drought scenarios for climate adaptation planning and water management, for decision making and real implementation. And the second, AI-based downscale to help improve local climate forecast at a small area, 1 kilometer levels areas. This help community prepare better for floods and droughts. Under MOU between DCCE and Western New, we hope that the collaboration will enhance for the local climate projection and climate risk at a small scale, and as well as about capacity building too. This will help Thailand for more ready and better prepare for climate response in the long term. And the last slide. I would like to share this message from Celeste Saulo, Secretary WMO. She mentioned AI and early warning. She says that we must mainstream AI power, weather, and climate intelligence into every early warnings and decision-making system because life depends on it. Let us ensure AI become not a barrier, but a bridge, not a luxury for some, but a lifeline for all. Thank you for your attention.
Thank you, Rabiab-san. AI becomes a lifetime for all. Oh, that's great. And we could understand how digital twin can help adaptation, and also climate change is also a big risk. But by using AI, 1 kilometer downscaling, it must be a great opportunity to protect Thailand's society. Okay, thank you. Shall we move on to the next? Dr. Seree, I would like to share the national strategy of early warning for Thailand.
Yes.
Thank you.
Yeah, thank you. Good afternoon. My name is Seree Supratid. Actually, I graduated from Tohoku University last 30 years, but still work. At that time, no AI. But now, AI is essentially, so I have to follow this one. Okay, as you know, the DPM is, we can call that, is a defendant of the issue. It means that we have to finalize the message, disseminate message to the people. This legally, this is the message. This is the issue important. That's why even though you have a very quick AI, but we have to construct in how the message we send to the people. Right? Like last year in Hat Yai, we send the message, more than 10 messages before the flood. But still, the AI should go along with the people and also the experts. Right? So that's why local people believe to their leaders. Right? Their leader tell anything, they have to they follow. Yeah? Maybe they just know that, oh, I got AI. I want to ask tomorrow when they have extreme flood like this. Sometimes they ask me that will be this year we have a great flood like 2011. So something like that. They need very how we call it, very accurate answer. So that's why one of the things that we have to go. Okay, we have not so much time. I just go past sometimes not so important. But actually, as I told you, legally we have to disseminate the message. Yeah, that's why one thing that I want to show you this one. You see, of course we obtain the information from many agencies that ONW says about more than 50 agencies, and then we have to compile them in one message, right? That to send to people. That's why the most important in the herd, you see, I just like make a herd. That's why how local people will respond to this message. That's very important. I will show you, okay? This in Thai, I'm sorry, I go to. We just have the cell broadcast last year after the big earthquakes. And then the normal people or politicians always needs us. Why? You don't send cell broadcast to them even though the earthquake magnitude about 2, 3, something like that, right? So we ask that we have the SOP of us that if the earthquake is more than 4 or the intensity more than 4, we will send. But the people or the politicians always like us to send. Every time they ask cell broadcast, something like that. So that's why cell broadcast become defendant. I mean, yeah. That. Okay. Yeah. Now actually we have a 2 alert system. We have Thailand alert system. The central government will send the information in case of earthquake, tsunami, storm, and extreme cold. And the other thing, flood, mudslide, PM2.5, the local people should warn yourself. This we set up this one. But now they don't warn because of, as I said, if the local people, the governor send the information to the local people, right? It is false alarm, something that maybe what they will tell to the people, right? Maybe they will, how we call it, they will force to go to another province or to go down, something like you send the misinformation. But in experts' opinion, we know very well that false alarm can be like a tsunami is more than 80% false alarm, right? But why the Japanese people accept that? Yeah? That's why for Thailand it's a custom, something like that. You tell the people you have to be very careful in the message. Okay, that's why you start like this one. Yeah, the last column is the local people. The middle column is the central government. We send everything to them, and then they send something like that. That's why we need we need the AI technology. We need help from Western news that to tell very, very high resolution. Sometimes we have no measurement, we have no station data. We have to use the radar, something like that. Okay. For example, I just give you one example. Okay, about 2 minutes. Okay. Yeah. Now it's a very hot issue. Every people, Bangkok people said that Bangkok will be flooded in the few years. That's why a big topic now. So we try to make that. So we use AI to forecast climate change effect in terms of the rainfall, in terms of the discharge, in terms of the sea level rise, something like that. Okay, I just go past. This is all the variable that increase. Okay, and then we come to back to like this. You see this is the Thai Gulf. We have 3 provinces. The left side is Samut Sakhon, the middle one is Bangkok, and then the right one is Samut Prakan. So the people see like this, oh, we cannot stay in Bangkok and on. Yeah, you see, almost the shade like this one. So how we can solve the problem? This one, so I need the Western News to help me. Yeah? How to explain to them like this, okay? We will cooperate later on, okay? And then for the Hat Yai, yeah, Hat Yai usually very pain to us in terms of, you see, if the rainfall is one day in the midden column in 21st of November, the daily rainfall is more than 300 millimeters. Yeah? 3 days about 600, so 3 days. Okay, this is the 200 year to 300 year return flood, return rainfall. That means if you see the magnitude of the return period here, the blue one is the nowadays, the red dot one is in the near future. 200 years return period rainfall become 15 years. So that's why it's very big, important, very issue for us to decide the infrastructure for Jai. Okay. Oh, finished already. Thank you very much.
Thank you so much for your awareness of the time. So lastly, thank you very much for Fatah-san give us a short comment with us. For how do you think the AI technology can be effectively utilized in early warnings in Thailand?
Okay.
Yes.
AI technology is a trend of now. It's very important for analysis and help for the I hope that when we use AI, it's more accuracies. Such as the radar that I talked before, at the first time I use movement. I know the extrapolations. After that, we use optical fold. But optical fold movement, not detect the topical convective development. They cannot. But I think this when we switch to the AI, CNN, LTM is better for learning from the historical data. I think have some gap of the AI because if the pattern that have no data, such as extreme event, the AI cannot catch something like that. And the NVIDIA's present in the morning part is very important. They can downscaling in a small size. And I have a small size is very important because is a support impact-based forecasting also. And the public event is very important, but I have many instruments, many models, how I merge together. Now we have more informations, but I don't want, I cannot too much together what I believe, what I test this model, I don't know. Is a gap of the Thailand also. And I have some problem because it's in the Hat Yai event, it's a big flood in Hat Yai. In the pattern is a very wide patterns. Is a closer from the China's coming to the southern of the Thailand. And the FFTS system is a collect point in the area. But false alarm is too much. When you downscaling, you need to receive the false alarm also. That pattern is like a warning in the half of the southern regions. It's a collect is also one point is collect, one point event is collect. But false alarm is too much. You use like Dr. Seree talk about, if you more false alarm, the last time, the next time the villagers don't believe you. Is the concern about that. Yes, thank you very much.
Thank you so much. So I received the passion of your organization today. So we Weather News do want to be a kind of bridge linking to the AI technology to enhance the AI early warning in Thailand. So thank you very much for your great panelists today. Shall we wrap up today's session? Thank you. Khop khun krap.